this video, we are going to talk about ionic compounds. In order to talk about ionic compounds, we need to talk about ions first. So, an ion is a charged atom. An ion is a charged atom. And the only way atoms can become charged is if they gain or lose electrons. So, an ion is made when an atom gains or loses electrons. Now, a cation is a positively charged ion, which means that it's going to have to lose electrons. Because the only way an atom can be positively charged is if there are more protons than electrons. And since we can't change the identity of the atom, which that would happen if we change the number of protons, we need to change the number of electrons. So in order for an atom to become positively charged, it needs to lose electrons. An anion is a negatively charged ion. And this happens when atoms gain electrons. So an ionic bond is the result of the attraction, and we can say the positive and negative attraction between a cation and an anion. So these compounds are held together by the positive negative attractive forces as a result of a transfer of electrons. Generally, the cation will transfer its electrons to the anion, which will make the cation positive and the anion negative, and those charges are what will hold the ionic bond together. Now, a compound with an ionic bond can be called a formula unit. So notice this is not a molecule. You can call it an ionic compound, or a formula unit. When we look at representing these formula units, ionic compounds exist in what we call lattices. Notice we have long-term patterns, and they're all going to have their unique pattern in the way they bond together. So this is sodium chloride, its crystal structure, and this is a space-filling model of sodium chloride. All right, let's look at naming ions first. When you're naming monatomic cations with fixed charges, you name them by using the metal name plus the word ion. Now, something I want you to keep in mind is monatomic means one atom. So this is a cation that only has one atom, and in that case, it's all monatomic cations are going to be metals. So when you look on the periodic table, all of the metals are going to turn into cations. Now, the ones that have fixed charges are going to be in groups 1, 2, and 3. And that is because transition metals generally have multiple charges. For this class, we are going to learn 3 transition metals that have fixed charges. So that is zinc. Zinc always has a 2+ charge. It will never have more than that. Cadmium. Cadmium always has a charge of 2+ as well. And then finally, silver. And silver has a charge of +1. So these are the transition elements um, that you must know the charges of. Groups 1, 2, and 3, you can look at the periodic table, know the charges of them. Transition metals, you can't. So these 3, I do require you know. Zinc has a 2+, cadmium has a 2+, that should be a D, and silver has a +1. So let's name the following monatomic ions. Remember, when you're naming ions, you take the metal name and then add the word ion. So Na plus, I know it is a cation because it has this positively charged symbol. If it was just the atom, it would just have the symbol Na. So this would just be sodium, but by adding the positive charge, we now have sodium ion. Ba is barium. So Ba2 plus is going to be barium ion. Al is aluminum. So since it has the 3+ charge, it's going to be aluminum ion. Silver, it's not in group 1, 2, or 3, but it is in our transition metals that we need to know. So it only has 1 charge. So we call this silver ion. K is potassium and it is charged, so it's going to be potassium ion. Finally, we have Zn, which is zinc. Zinc is also one of the transition metals that has a fixed charge, so we would name this zinc ion. When you are naming monatomic cations with multiple charges, so these are going to be the transition metals plus tin and lead. So essentially, we can't look at the periodic table and determine the charges on the transition metals, and we can't look at the periodic table and determine the charges on tin and lead. And furthermore, they have multiple charges. So remember, transition metals don't include the zinc, cadmium, and silver for this example because those have fixed charges. We're only talking about transition metals with multiple charges. And we want to still use the metal name, but now we're going to use Roman numerals to represent the charge. This is very important. It is the charge of the metal. So we'll use the metal name plus the Roman numerals plus the word ion. So in our first example, we're dealing with iron. We have Fe, and it has a 1+ charge. So I'm going to name this using my metal name. I have a 1+ charge, so the Roman numeral is going to be 1. And I'm going to add the word ion. In our second example, we still have iron, but notice our charge has changed. Now we're dealing with iron with a 2+ charge. So we still have iron, but since our charge is now 2+, we need to use the Roman numeral 2 And then, of course, add the word ion. In our third example, we have Cr, which is chromium, and my charge is 3. So this is chromium 3 ion. In number 4, we are dealing with Pb, which is lead, and the charge is 2 plus. So we'll name this as lead 2 ion. Number 5 is manganese, and it has a 5 plus charge. So we will name this manganese 5 ion. And then finally, we have Sn, which is tin, and this ion has a 4 plus charge. So we would name this tin 4